Hi everyone, today we're going to discuss pseudocode. The word pseudo means almost. The word code is referring to the source code, which are the instructions that the computer has to understand in order to run your program. Pseudocode is almost code, a way of writing things down that is less strict than computer code, but more clear than informal English. What we're aiming to do is describe what needs to be done without telling somebody exactly how it needs to be done. Once you've written your algorithm in pseudocode, it doesn't matter if the person programming it needs to create it in Python, in Java, another programming language, or do it on paper. They can understand the steps and translate them into the purpose that they're doing it in, so whichever language they need. We want to make our algorithms detailed and specific without having to get into those fine details that programming languages have in them. We don't want to get all confused with brackets and semicolons and things like that when what we're trying to do is express an idea. We're trying very, very hard to separate the problem solving that's required for inventing our solution from the problem solving needed to create a computer program. When using pseudocode, it's really important to use clear, direct language. Each line of pseudocode should start with a verb. In our course, I'm going to ask you to use the convention that you capitalize the verbs to make them stand out. Each line of pseudocode should only perform one action. If you're going to use the word and, probably has to go on the next line. Okay? Why? Well, because even though we're not trying to write computer code, that is our goal. We want to be able to take what we get in pseudocode and have it transfer over very nicely to computer code. So, we want to write something that we can say this line from the pseudocode became this line of the program. Some programming languages would be great and let us do multiple things in one step, but not all of them. So, let's try a simple example. What I want to do is get the user to enter two numbers. I'll add them up, and I'll display the result back out. So in our IPO, we've got input two numbers, P, get the numbers, add them up, and O is the sum of the numbers. So what would that look like in pseudocode? Let's make it a little more formal than just hand waving. Okay, so the two numbers I want to get are the inputs. Words like read, get, obtain, words like that are good to use when describing actually getting the inputs from the user. So we start our algorithm off with get two numbers from the user. We might be able to do this in one line of programming, we might not. We don't want to worry about that level of detail. That's a programming detail. That's what the programmer does. We're at a higher level right now. We're the designer. Okay? We just want to worry about that one action. Get two numbers from the user. Doesn't matter if we get them at the same time. Doesn't matter if I get one now and one later. None of that is really important. Stick to the core idea of what you're trying to do. You'll get a feel for what is fine-grained enough once you do start coding, because you'll start to see what you can do in one step, what really is two steps, and so on. Okay. We have a calculation step, which is adding the two numbers together, and we should start that off with a word like compute or calculate, something like that. So I might say, calculate the sum of the two input numbers. Next, our deal with the user is that if you gave me the two numbers, I would show you the sum of them added up. So that's what we need to do next. For outputs, words like print or display or show are simple and easy to understand, so we could write show the sum. Now, for a small, simple program like this, these three lines might be fine. It relies on somebody knowing what a sum is, but that's not too much to ask. If our program was more complicated though, we might want to attach names to some of these things to make it clearer for the reader. In other words, what we're going to do is we're going to use variables. We can use the word set to indicate that we're going to give a name to a value. Or sometimes it is convenient to do something like use the word as, or as long as we're clear on that it's not an equation to be solved, we can use an equals sign. So for example, my line, get two numbers from the user, could become get two numbers from the user, set x as the first number, set y as the second number. That's a little clunky though. So we could just more simply say, get two numbers from the user as x and y. As long as we understand that that's means the same thing, we're off to the races. We could have also said on the calculating step, calculate x plus y as z, following that same theme. But because this is a math equation, as long as we recognize that z equals x plus y is not something that you're going to solve, that you are saying z is the name that I'm giving to the value xy, then we can say calculate z equals x plus y. It sounds like a bit of a word game that we're playing here, but the meaning is going to be important later on, because when we start writing these programs into Python, it's really important that we put the right things on the right side of the equals sign, because we're not setting up equations in math and you can't rearrange things. If you rearrange them, you get different results. Okay, so finally, if we've got that variable z set up, then we can just say show z. If you really want to, you could say show z, but I'm not going to. Alright, so all of these styles would be correct. Some are going to appeal to you more than the others. In the past, we've required the use of variables to have those separate set lines, but I think as long as you capitalize your as clause, I think it's really clear and readable what's going on. We can also document any assumptions that our algorithm needs. Now for this one, we don't have any. But let's say, for example, that you only wanted the numbers to be between 1 and 5. Right? So then your biggest sum could be 10. Then at the start of the program, we can add the line, assume the numbers from the users are between 1 and 5. Then we have to decide, is 1 included, is 5 included? If they're both included, then we say inclusive. If they're both left out, so if the only valid numbers are 2, 3, 4, then we can say exclusive. Now, it gets a little bit more wordy when you want to say, well, 1 is in but 5 isn't, or something like that. We have a small mathematical notation for this, but you have to be really careful not to use it as Python code. Okay, it will not work as your Python code. We're going to use greater than and less than in Python code. But this notation uses square brackets to mean inclusive and round brackets to mean exclusive. So if I write down something like square bracket 1 comma 5 round bracket, this means give me the numbers including 1, 2, 3, 4, up to but not including 5. And we can mix and match where the round brackets are and where the square brackets are. So you could have a round bracket at the start, would mean don't include 1. Now, when we're working with integers, you can probably avoid this altogether. You could have said from 1 to 4 or from 2 to 4, and we would all know exactly what you mean. But where this becomes really important is when we start working with decimal numbers. With decimal numbers, I can go to 4.99, I can go 4999, any number that you want as close as you want to 5, but not exactly 5. That's where this becomes a little bit more helpful. Now we can say the exact same thing using greater than or less than signs and putting equal signs wherever we want. And this is what we'll end up doing when we're writing it in Python. But again, there's going to be rules around that too, so we'll get to all of that in a couple of lessons. Whichever notation you want, just pick one that is precise and unambiguous. In other words, make sure I understand exactly what you mean when you write it down. When it comes to math equations can go right into pseudocode. Why? Because by their nature as math equations, they're already precise and unambiguous. There's an agreed upon set of math symbols. Now, the only spot that I can think of right off the top of my head that's going to be a problem is exponents. Because you're not supposed to use programming language codes, and you're not supposed to use any kind of weird non-standard notation. It's supposed to be perfectly clear. But the caret symbol, the little hat over the number 6, that is usually used to mean exponent, because it comes from the C programming language. And we don't use it in Python. So that's where the confusion comes in, right? So if you were to write something out like x to the power of y as words, that's probably the best for getting started with. The reason being, it's a little bit wordy, but there's no confusion. I don't want you using Python code inside of your pseudocode. Now, this caret symbol is probably widely well enough known that you could get away with using it. But again, when going from pseudocode to Python code, make sure that you're doing it carefully. Make sure that you're not just copying things over, because things like this won't work and they will bite you in the butt. Okay, so there are whole books full of algorithms designed for accomplishing different tasks. If you look on Wikipedia, you'll find all kinds of algorithms written out in pseudocode. Most of them can be programmed into a computer today, even though they may have been designed 50 or 60 or 100 years ago. They still work wonderfully. Okay? Just remember, we're not trying to write an algorithm that will work on a specific computer. We're trying to write an algorithm that solves the problem, and it is up to the programmer in the implementation step to go ahead and figure out the details of how to make it work. That's all I have to say about pseudocode for right now. Until next time, I'm Stephen Adams, and I hope you're having a great day. Bye for now.